Okay, so in section 3.2, we're going to use a lot of the pairs of angles that we used in 3.1, but now we're talking specifically about parallel lines. So notice it says use parallel lines and transversals. So they've got numbers on these postulates. I don't really care about the number. So I know it says postulate 15. I don't care about that, but we do have the name here, corresponding angles postulate, and I believe these are already on your definitions sheet. Should be able to find it there. But it says there if two parallel lines, that's different than what we had yesterday, so now they have to be parallel. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So you see in this picture, we've got parallel lines P and Q. They have the arrows on them, so that marks that they're parallel. And then there's this transversal, it's line T. It's going to create corresponding angles. 2 and 6 are one of the pairs of corresponding angles. They're not the only pair of corresponding angles, but that is a pair of corresponding angles, and it tells us in this postulate that they're congruent. So I know that angle 2 and angle 6 are congruent. Well, if I wanted to mark in the other angles, have 1, 2, 3, 4, 5, 6, 7, 8. Now I could also list other pairs. Like angle 1 would have to be congruent to angle 5 because they're corresponding. Angle 3 and angle 7 are corresponding, so they have to be congruent. Angle 4 and angle 8 would have to be congruent because they're corresponding. And then we already had the 2 and the 6 listed. So there's more pairs than just the one, but that was just showing you one example of corresponding angles. Okay, so there in example 1, it kind of uses that idea. It says identify the congruent angles. The measure of 3 of the numbered angles is 120 degrees. We have to identify the angles. We have to tell which other angles are 120 degrees. Actually, we should be able to do that. And they want us to give an explanation. So one of them is using the theorem that the postulate we just came up with. And we have the 120 right here. The lines are marked parallel. That's important. If they weren't parallel, we wouldn't know anything. Because they're parallel, 120 and angle 5 are congruent. So angle 5 equals 120 degrees. And it's by that corresponding angles postulate that we just had. Okay. Now, we also, if we go back to last chapter, we talked about vertical angles. 120 and this 120 degree angle, which is angle 1 and angle 4 are vertical angles. They're congruent to each other. So I know that angle 4 is also, its measure is also 120, and that's by the vertical angles theorem. And now I just called angle 5 120 degrees. It's got a vertical angle of angle 8, so angle 8 also has to be 120 degrees because of the vertical angles theorem, or because it's corresponding to angle 4. So you could use 2 different reasons on that one. But 2, 4, and I keep writing 4. That's not 4. That was 5. I wrote no. 5 was right. 5 was right here. Okay, sorry. So I said 5 initially. 5, 4, and 8. That's correct. 5, 4, and 8 are the 3 angles that are also 120 degrees, using corresponding and vertical angles. Then we also learned about some of the other pairs. Alternate interior angles. If the lines are parallel, alternate interior angles are congruent. So there's an example of alternate interior angles is 4 and 5. We also know, if I wrote in the other numbers, that 3 and 6 are also a pair of alternate interior angles, so they're congruent as well, as long as the lines are parallel. Alternate exterior angles. So we've got 1 and 8 as an example. They have to be congruent as well. So the lines are parallel, they're alternate exterior, they're congruent. The other pair that's not listed on there would be like 2 and 7. So angle 2 and angle 7 would have to be congruent as well because they're a pair of alternate exterior angles. And then we've got consecutive interior angles. This is kind of the odd one out. So all 3 of those so far, corresponding angles postulate, the alternate interior angles theorem, alternate exterior angles theorem, All three of those result in congruent angles. If you look at the consecutive interior angles theorem, these two angles are not congruent. If two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary, which we know means they add 180 degrees. So 3 and 5 are supplementary. They add 180 degrees. Angle 4 and angle 6, that would be another pair of consecutive interior angles. So 4 and 6 are also supplementary. We don't know that they equal each other. I don't know they're congruent, but I do know that they add 180 degrees. The only way they'd be congruent is if they were both 90. Okay, and so then we get to this example 2, and it'll be the end of the notes. It's pretty short notes today. But they want us to go ahead and solve for x using any of those ideas. So x shows up in this angle down here. It's a consecutive interior. It's on the same side of the transversal, an interior with 4. So if I knew what angle 4 was, that would be helpful. Well, 4 is a vertical angle with the 115, so they have to have the same measure. So angle 4 has a measure of 115 degrees. And then that 115 and the x plus 5, they're consecutive interior, the one we just had. That means they're supplementary. So they have to add to make 180. So I can say 115 plus x plus 5, together they equal 180, because they're supplementary. I can combine the like terms. I have the 115 and the 5 that can combine together to make 120. And now I can subtract 120 from both sides. So I see that x has to be 60. So we answered the question.